Okay, today we're going to go over in this video lesson 78. This is Algebra 2, Saxon Algebra 2. This is lesson 78. All right, in lesson 78, we are dealing with force vectors at a point. All right, so we're going to have a diagram like this. Here's my base. I've got something coming in this way and this way. And right here, there's going to be a pulley of some sort. Okay, and so what's happening here is something is being pulled or pushed. All right, and so I have a 30-degree angle here. Ignore the fact that I didn't draw this very much to scale. All right, this is going to be a 30-degree angle, and my length of rope that I've got here is 40. Over here on this side, this is a 45-degree angle. All right, and the length of this over here is 70. Again, clearly not drawn to scale at all. We'll make this one a little shorter. How's that? Okay, and this is being pulled this way, and this is being pulled this way. All right, and so we've got these two ropes. They're attached to a point, and they are pulled on with the directions and the magnitudes. All right, so what I've got here is I've got one rope being pulled at this 70 at 135 degrees. All right. And then the other one is going to be 40 at 30 degrees. Okay. And notice I've got this 45 degrees over here. That's because where that is 135 degrees, here's my 135 degrees. Okay. And then I have another 45 here. Okay, so I'm going to wind up looking at this 45-degree angle here, we'll drop a line here to create this triangle. So that's why I have 45 degrees there in my drawing. So you're going to be given this idea that we have two ropes attached to a point being pulled on with these directions and these magnitudes. All right, and what they want to know is what is the resulting force on the point? What is the resulting force on this point here? Okay, so what I'm going to need to do is, form my two triangles, and I'm going to need to be able to find the rectangular coordinates for these so that I can add them together. Okay, looking at this angle right here, this side is the opposite, this side is the adjacent. Looking at this triangle, this is the opposite, and this is the adjacent. All right, so I'm going to use my sine, cosine, and tangent in order to calculate those values. All right, so over here, I'm going to have that the opposite is going to equal 70 sine 45, which you're going to plug in your calculator. You should get 49.497. All right. The adjacent side is going to be 70 cosine 45, which is going to give us a negative 49.497. All right. Dealing with this other triangle here, I've got the opposite is going to be 40 sine 30 degrees, which is going to give me a straight up 20. The adjacent side is going to be 40 cosine 30 degrees. When you plug that into your calculator, you're going to get 34.64. All right, so that's giving me over here that this side is 34. Actually, I just wrote that on the wrong place. Never mind. Okay, so that gives me this side over here is 20. This side over here is this 34.64. Okay, this side over here, these are both going to be the same. This one's, 49.497. This one is going to be negative 49.497. All right, those are the lengths of those sides. Okay, so now we've got this in our rectangular form, and we're going to combine these. Okay, so looking at my total, left to right. All right, as I look at that, I have this negative 49.497. I have this positive 34.64. So my total that I have there is going to be negative 14.857. Okay. My up and down force. All right, so for my up and down force, I have 49.497 plus 20 is going to give me 69.497. Okay, so now I have the rectangular coordinates of this resultant force. Okay, so I can say that my resultant force, which is what you're looking for, is going to be negative 14.857 R and 69.5 U. Okay, now though they do want this expressed in the polar coordinates. Okay, we've got the rectangular coordinates there. So it can help a lot to draw a picture. Okay, so looking at this, okay, this is telling me that my right and left is going to be negative, okay? And it's going to come over, here, and this length here is going to be 14.857. Now look at this. This right here is going to come all the way up here. It's going to be really, really long, okay? Should be, taller and skinnier, actually, in reality, because this over here is 69.5 units tall. All right, and what we're solving for here, we have to find theta. We need to find that angle. Okay, so this is my opposite, this is my adjacent. Those are what I know, so I'm going to find the tangent. So my tangent of theta equals the opposite over the adjacent. All right, so here I'm going to wind up with 69.5 over 14.86. All right, so this is telling me that the tangent of some angle is going to equal 4.677. Okay, so in your calculator, you're going to use your invert tangent feature. You're potentially going to need to hit the second button or something to where you get that invert. All right, and when you calculate that, you're going to find that theta equals 77.93 degrees. Okay, so that's telling you that this over here is 77.93 degrees. Okay, so think about, though, what we're going to have to calculate is this measurement right here. All right, this is what we have to calculate. Okay, so we're going to have to do 180 minus this 77.93. Okay, when we do that, we're going to get 102.07. So my resultant force now, I've got, this 102.07 degrees. Okay, remember what goes right here is the hypotenuse of the triangle. I don't know my hypotenuse at the moment. I do know that I've got this triangle, okay? I know that this side is 69.5 and this side over here is 14.86, and I need to solve for my magnitude. I need to solve my hypotenuse. Okay, so there we're just going to use 69.5 squared plus 14.86 squared equals my magnitude squared. So we'll square these, we'll add them, we'll take the square root. Okay, so when we square those and add them, we get that, 51 equals m squared. Take the square root of both sides. So we're going to get that m is approximately 71.07. So my actual answer is that the resultant force, okay, is a magnitude 71.07 at 102.7 degrees. Okay, so this is the angle and pole that must be used with a single rope to get the same result obtained from using 2 ropes, okay? So in the original, we had something that was probably supposed to look a little more like this, let's say. That's still probably not great, but anyhow. Originally, I had 45 degrees here, and I had a magnitude of 70 there. I had 30 degrees here, and a magnitude of 40 degrees there. And they were being pulled in the opposite direction, and they applied a force right here. Okay? Well, if I want to apply that same force, but only use 1 rope instead of 2. I'm combining the 2 and I want to just use the 1 rope. What I found now is that I'm going to need a rope, all right, with a magnitude of 71.07, and it's going to have to be at 102.07. Oh, I forgot my 0 here. 102.07 degrees. With a magnitude of 71.07 in order to get the same force on this point right here using just 1 rope as compared to 2. Okay? All right. Those problems are pretty big. There's a lot of steps. Do plan on going back and watching the video probably a second time and just working several of these problems. Okay? Another one that we're going to do, we're going to look at the idea that a pushing force from the left is the same as a pull from the right. So here I'm going to talk about having a force of 10 pushing, okay? And then here we've got this 16, okay? We're going to carry this on over here. And look at the idea that there's going to be 30 degrees right here. Okay? And that we've got a push force. Okay? And so right here is where this force is ultimately. We've got this being pushed here, and we've got this pull force here. Okay? So a push from the left is the same as a pull from the right. All right, so what we want to do is rewrite the equations to show both vectors as a pull force. All right, so let's look here. We're going to create our triangle. All right, here's my triangle. And this thing here, I love the fact on one hand that it makes this for me. On the other hand, if I don't do it just right, it makes my triangle not the way I want it to look. Okay, so I've got that. We're going to have this 30 degrees here. All right, we're going to have this 16 here. Okay, now I said that the push force is the same as the pull force. So this, we can bring that 10 over here. All right, and what I need to do now is find this. All right. Okay. So let's look here. If I've got that 16, okay. If I have this 16 here, I'm going to have this 16 cosine 30 is going to give me 13.86. All right. And then we're going to have 16 sine 30 is going to give me 8. Okay, so I have, with this, we're going to look at 2 things. We've got this then that's going to be able to have my 13.86 right, okay, and my 8 up. All right, and then here we're going to have where we've got just this push coming in here, right, where we have this push coming in here, that's going to give us the 10 to the right, but it's not going up at all, so we're going to have 0 up. All right, so we're going to add those things together, and we're going to get 23.86 R, and we're going to get 8 up. Okay, so now let's look at this as we combine those two together. We're going to have this triangle here, and this is going to give me 23.86, and this is going to give me 8, and we're going to pretend that that was straight, like it should have been. All right, this right here should be a 90-degree angle, and what we're solving for now is what is this angle here, okay? So what I'm going to need to do is find the inverse tangent of 8 over 23.86. Go ahead and divide these to get the amount that you're going to key in for that inverse tangent. So with that, my total that I'll wind up with is 18.54. Okay? All right, so that's going to be what that angle is. This is going to go right in there. All right, I need to solve there for my magnitude still. So m squared equals 8 squared plus 23.86 squared. Okay? So m equals the square root of 633.3. And so m is going to be 25.17. Okay, so my resultant force is 25.17 at 18.54. Okay, so going back and looking at the idea here that I've got this push coming in here. This is being pushed. This is two different things happening, okay? So just to clarify, that here we've got this push happening here. It's just a push. There's no upward pull, all right? But then over here, we have this, okay, where we've got that pull that's going to be, out at 16 and up at a 30-degree angle. So what I've done is I've combined these two, okay? So if I want to see what this right here is telling me, if I've got a push in at 10 and a pull up here of 16 at 30 degrees, okay? All right, if I combine the two, and I want to be able to do this with one rope, okay, what I'm going to wind up having to do the same thing with one rope is I'm going to have something coming out like this, okay. The length of this is going to be 25.17, and the degree here is going to be 18.54, all right. So then I would just have this one rope pulling there. All right. I know these are a little hard to imagine exactly what's going on. All right. I hope that helps. Again, if you have any questions, make sure you reach out to me.